Now we want to look at two sample estimation. So when we're dealing with two samples, we're actually estimating the difference between the population means or the difference between the population proportions. Okay, so just like with one samples, we can have a situation where we don't know the standard deviations, the population standard deviations, in which case we use the two sample z interval. If we can have a situation where we know the population standard deviations. Okay, in that case, we're going to use the two sample z interval. We can have the situation where we don't know the population standard deviations, and in that case, of course, we use the t interval. So that's just like with the one samples. Or we can have two proportions. That's dealing with qualitative data. Okay, so we're going to come back and look at this in just a minute and talk about how we interpret some of these examples. Okay, let's look. I'm going to go down to this bottom one for our first example here. During a recent survey, the average salary for licensed social workers was determined to be $49,500 based on a sample of 55 licensed social workers. A survey was also conducted for the average salary of unlicensed social workers, was determined to be $34,200 based on a sample of 50 workers. Assume population standard deviations for unlicensed workers is 5,500 and population standard deviations for licensed workers is 4,500. So we're going to construct a 95% confidence interval for the difference between licensed social workers and unlicensed social workers. Okay, so let's write down the information we know. So in this case, for the licensed social workers, we know the average salary. So this was based on a sample of 55 licensed social workers. So the average was 49,500. So we know that's the sample mean because it was based on the sample of 55. This was the average. Okay, and it tells us down here that the population standard deviations for licensed social workers is 4,500. So that's our sigma. So I'm just going to put a little subscript of 1 by both of these. Okay. Going on with my line here. All right. Now for unlicensed, social workers, it tells us the average salary sample was 34,200, sample size of 50, and down here it tells us for unlicensed the population standard deviation was 5,500. Okay, we're going to use a little subscript of 2 for these. So what we're really estimating is the difference in the population means. Okay, so the way we do that is we go in our calculator, we go to stat, over to test. Okay, because we know the population standard deviations, we got to go all the way down to intervals here. Don't go to the test yet. Okay, so we want either 2 sample Z or 2 sample T. Which one do you think? Yep, 2 sample Z because we know the population standard deviations. We have our data. So for our first sample, the population standard deviation was 4,500. For the second sample, it was 5,500. Our sample mean in the first sample, let me move mine out of the way here, was 49,500. We had a sample size of 55. The mean for the second sample, the unlicensed worker, was 34,200. When that was a sample size 50. Our confidence level in part A here is 0.95. And we calculate. Okay, so give 13,000 gives us a confidence interval of 13,366 to 17,234. Okay, so if I write this as my inequality, the difference in mu1 minus mu2 is between 13,366 and 17,234. Okay, so what we're estimating is the difference. So think about that. That's saying if we subtract the population average of licensed minus unlicensed, the difference would be between 13,366 and 17,234. Okay, so basically what that's telling us is if we subtract these two, this answer right here falls in between these two numbers. Okay, that's what it's telling us. Since both of these numbers are positive, it's telling me that this answer is going to be positive. Okay, if this answer, when I subtract these two numbers, is positive, that means which one is larger? That means mu1 has to be larger in order for this answer to be positive. That makes sense? So in our interpretation, we are going to say we are 95% confident that the population average salary, okay, so since I'm saying here that mu1 is larger, that means that this was my 1, this is my sample size 1, right, is larger. So I'm saying I'm 95% confident that the population average salary of licensed social workers is larger than unlicensed social workers. Does that make sense? This is how we need to interpret these. Okay, so if we go back up here to this interpretation here, here's what I'm saying here. Okay, if both of these answers are positive, which is what we just had, then mu1 is larger than mu2. If both of these answers are negative, then mu1 is smaller than mu2. Okay, so what that's saying, remember what you're estimating is if I subtract these two, what's the answer here? Okay, in this first one, we're saying they're both positive. In the second one, I'm saying they're both negative. So if they're both negative, that means I'm saying this answer is negative. So in order to get a negative number, that means mu2 has to be larger. And that's why we're saying here mu1 is less than mu2. Okay? If one's positive and one's negative, then basically what I'm saying is I can't conclude at this level that either one is bigger. Because if one's positive and one's negative, then that means this answer could be 0. Okay? Does that make sense? And the same thing is true with the proportions. Okay, let's look if we do the same thing, but we're going to use a confidence level at 99%. So we do stat, test, to sample Z. The only thing I'm going to change here, oops, I went into test, didn't I? Stat test down to, that was a Z test, sorry. We got to go all the way down to 2 sample Z interval, not Z test. My fault. Okay, so we want our confidence level to be 0.99. I knew I went in the wrong one because I didn't have that option. Hit enter. Okay, now my confidence is 12,759. and 17,841. Okay, so if I write that as an inequality, so what happened to my confidence here, it actually got a little wider. So sometimes I think about this in terms of when I make this confidence interval, if I do a 95% confidence interval, it's the area under the curve between these two values. When I change that, I have to make that area a little bit bigger, right, to make it 99. So that's why it gets a little larger for 99. Make sense?